All right, so I'm going to have to re-record the video that I had done earlier as part of this one because it did not capture any of the ink when I was writing with the pen. So this video is going to cover 7A1 all the way to 7A3. So the first part, 7A1, we're doing exactly kind of what we were doing in the 6B material. We're looking at these contingency tables. The only difference is that we're going to be applying kind of this concept of a medical false positive or a false negative. So notice it says, and there's my ink. The table below is a specific type of contingency table used to determine the effectiveness of a test. Suppose a person has a disease. The doctor will test for the disease, and this test will either give a result of positive, which means they have the disease, or negative, which means they do not have the disease. We can summarize the four possible situations a patient could be in using the table below. Now, the problem is these tests are not 100% accurate. So you have two things. You have a test coming back positive or a test coming back negative. And you actually have, is the person sick or not sick? So what is their actual body's state of being? Are they actually truly sick with that disease? Or is it a test that came back positive and they actually don't have it? So if you have the disease and the test comes out positive, remember positive on a medical exam means something showed up that they were looking for. So it's positive is actually a bad thing usually when they're testing for diseases. So a true positive means the test said they have the disease, the person actually has the disease. So it reported correctly. If the test comes back negative and that person actually has the disease, they received a false negative. And this one's to me, this one's the scariest when we're talking about disease, because that means that that test came back negative. So they're going to think that person doesn't have the disease. They're going to explore other options, but they may not come back and actually catch what the disease is for quite a while. So that could leave you untreated essentially for quite a while. And then this total is just all of the people who have the disease. Now, say you get a positive test result, but you don't have the disease. This is still an incorrect test. It's called a false positive. This is a little less horrible than the false negative, just because in terms of disease, they're going to at least still follow up because they're going to say, oh, you have something, we need to do more testing. And then they would usually find out you actually do not have that disease. So that's a false positive. And then a true negative is when it reports correctly. You get a negative test result, you don't have the disease. So the test gave a true response to your body's state of being. And then we have our total that do not have the disease. We also have our totals for our columns, the total of people that tested positive, total of people that tested negative, and then how many tests did they do when they were looking at this specific type. Now, it says a patient that tests positive despite not having the disease is considered a false positive. A patient that tests negative despite having the disease is considered a false negative. To find the probability of false positive, you're really doing it's like a conditional probability. You're looking at, because they did get a positive test, but we're kind of trying to figure out how many people got an incorrect result. So we look at all the positive results. So we're just hyper focused on people who tested positive, and we're looking for the number of those that were incorrectly positive. So the false positives. They tested positive, but they don't have the disease. The probability of a false negative on a blood test is going to be, if we focus on just the people who got negative results, how many of those were reported incorrectly? They got a negative on their blood test, but they actually do have the disease that they were being tested for. So that's how we're going to calculate these. So let's look at this first example. An oncologist wants to determine if a new brand of test is effective in detecting whether or not a patient has cancer. Complete the contingency table below. Okay, so we first have to fill in, this is just like last part when we were doing today in class, we need to fill in how many people are missing in these. So 47 to add to 50, we'd need 3 people in that group. We would need 43 in this group. Notice that adds to the 46. And if you add either the 2 row totals or the 2 column totals, you'll notice that they tested 100 people. Okay, so what is the probability that a patient tested positive, but they do not have the disease? Remember, that is called a false positive. Okay, so a false positive, probability of false positive is all the people who tested falsely positive over all positive tests. Okay, that's our formula for that. So the positive test is a row this time. So really this is conditional probability. So there were 54 people altogether who tested positive for that blood work. out of that group, testing positive means you have the disease. So notice there were 47 people who the test correctly identified as having the disease. The people who were falsely positive were, you got a positive test result, but you're not actually sick with that. So that would be the 7. Okay. So 7 out of 54 were false positives. Okay. Find the probability a patient tests negative, but they have the disease. What is this called? This number is called the false negative. So when we do a probability of a false negative, we look at all negative tests. So everybody who tested negative, and then we look for people who were falsely negative on top. In other words, it was the test reported incorrectly to their actual body state of being. So negative tests. So that's this second row. We had 46 negative tests altogether, and then falsely negative. So remember, negative means you do not have the disease. Okay. So 43 people, the test said you don't have the disease, and their body actually says, nope, you don't have the disease. Those were correctly reported. There were 3 people who had no sign of that disease in their blood, but they actually are sick with it. So that would be the 3 people who were incorrectly reported. So 3 out of the 46 negative test results. Okay. Now, this next problem, it introduces a new definition. It's called a negative predictive value. Anytime you're doing blood work exams or test results or anything like that, and sorry, my table is a little off on this. Let me see if I can adjust that so you can actually see the words. Yeah, positive and negative. When you're doing these results, the accuracy of the test, in other words, how well is the test telling us true results, can be measured 2 ways. You can talk about the negative predictive value. So how many times is it correctly reporting negative test values? Or is it the positive predictive value? So how many times is it reporting the positive result correctly? Both of these are also still conditional probabilities. So this one's the negative predictive value. So this is for West Nile virus test. This means a true negative out of just the negative test. Okay, so we need to fill in our chart. Looks like we need 17 to make that add correctly. 17 plus 6 would be 23. Let's see, 19. We need to subtract 677 and 19. So 677 minus 19 is 658. That gives me that bottom row part. I could use those 2 numbers to find that. I can subtract 6 from the 658 to find that column part that's missing. That'd be 652. And I need that to add up, or I could have subtracted here, but I can add up or subtract from 677, that 23, to figure out the rest of this row. So that's a 654. Okay. So a negative predictive value means we got a true negative. So out of all our negative tests, we're still only hyper focused on that one type of test. We want to see people who were correctly negative. They actually, their test result matches their body's state. Okay. So we look at negative test results, and sometimes in the homework notice, they'll change whether positive or negative as a row or a column. So you do have to look for that. So we're just focusing on these negative test results. So this column right here. There were 658 total negative test results that came back to the doctor's office. And if it told you you were not sick or not infected, it did its job. Okay. So that would be the correctly negative. The people who the test came back negative and they do not have West Nile virus. That means the test and their body's state of being is in agreement. So that would be 652. And we're going to round in the directions our decimal to 4 places. So we need to do division. So 652 divided by 658. That'd be 0.9909 because the 8 would bump up that first 8. So 0.9909. So there's almost a 99% accuracy for it predicting you not having the disease. Okay. So that West Nile virus test that they were giving people, if it told you you had a negative result, that was correct 99% of the time. So it was only 1% of the population that it said you don't have the West Nile virus, and they actually did. That was those 6 people. Okay, so let's look at some more. An urgent care clinic wants to determine if a new brand of test is effective in detecting whether or not a patient has anemia. Use the table below to determine the probability the test gives a false positive. Enter your answer as a simplified fraction. So remember, false positive means we're only going to be focused on the positive test. Okay, so probability of a false positive is how many positive tests did the doctor's office receive? And then remember, false positive means it reported the test and it reported their body's state of being incorrectly. Something was an error in that process. So remember, positive, if it was doing its job, would mean you have disease. So we're looking at there are no disease people who tested positive. So that would be 2 people out of the 93, and that is a reduced fraction. So 2 out of 93 of the positive tests were incorrectly giving positives. An oncologist wants to determine if a new brand of test is effective in detecting whether or not a patient has cancer. Use the table below to determine the test. Now, this one you have to be really careful with. You have to read this. We want to know if it gives a false positive or a false negative. Okay, so that is a plus, remember. If you're doing an or statement, you're adding 2 probabilities together. And then if there's overlap, we have to subtract them. Now, there should not be any overlap here because the positive test is a row and negative tests are a row. So remember, you only get overlap with or if you have a row compared to a column. So since we're focusing on the test results, the positive and negative, we're not going to have overlapping information. So we're going to find the probability of a false positive, then find the probability of a false negative, and then add the 2 values together. So for the false positive, we have to look at only positive tests. So there's 135 positive tests. Out of those, 22 of them said someone had no, 22 of them said the test said you have the disease, but their body says no, they don't. So that's the false positives. Then we need our probability of our false negatives. Okay, so negative test was 105. And we would then look for those incorrect reporting. So negative means you don't have disease, but there were 7 people who got a negative test who actually are sick with that. So that would be false negatives. So now we're doing the or statement. So or means add. So we would be taking 22 over 135 plus 7 over 105. I'm going to do this on my calculator using my fraction button. So I do 22 over 135 plus 7 over 105. And my calculator, I have the TI-30XS multi-view that we recommended for the class. It tells me that reduces down to 31 over 135. Notice that it's not just adding these numbers together. That's not how that works because these are not common denominators, but the calculator I'm using is able to add fractions together. So if you did not have a calculator that does that, you would literally have to figure out what is a common denominator. One quick way to do that would be to multiply both of these by 105 and these 2 by 135, but you're going to have big numbers to try and reduce back down to this. So it's better if you actually learn how to use your calculator. Okay, so we're almost close to where the other video I had pre-recorded is. So let's talk about 7A.2 part 1. So data distribution shapes and the symmetric versus skewed. So when you take data and you actually put it into what we call a histogram, that's a bar graph where none of the bars are gapped. So notice they're all touching each other. And we're going to talk about how to make these in the next section. So if your data set is balanced, we call that symmetric, okay? In other words, you find that the peak has about an equal distribution to the left of it and to the right of it. It almost looks like a nice, perfect bell shape, okay? Then you have 2 different types of skewed. Now, skewed data has to do with when you have, like, say you had a group of students come in and take a test, and like, let's say out of the 30 students, 29 of them, or no, let's say 27 of them made a C on the test. Well, if the other 3 make zeros, that will pull my average down. If the other 3 people make 100, that would pull my average up. So that's what's happening when you skew data. You have some what we consider not typical values that are making your average either bigger than it should be or smaller than it should be if we were symmetric, okay? So I like to look at this as kind of like a whale. Think about that being like the blowhole of the whale. So notice that there's more, this is our peak, There's more data spread to the right. We are stretching out further to the right than we are to the left. So this one is considered to be skewed right. For this one, notice this one has the hump again, but it has way more data stretching to the left, like the tail of your whale, okay? So wherever the tail of your whale is going, if you imagine this being kind of the blowhole of the whale, that's where they're skewing. So this is skewed to the left. So this first example in pink, that would be the people who are, you have a lot of students kind of scored in the middle, but then there were quite a few students that just scored really, really high. They brought the average up. The second one here, this would be most people scored in the middle, but then you had a few people who didn't even take the test. They all got zeros or something really low, and they pulled the average down. Okay, so that's the easiest way to kind of think of those, is to think of it in terms of like, you know, a test score. That helps you kind of visualize that how that average would move. Now, if your data is skewed left or symmetric or right skewed, we can actually talk about the mean and the median. Now, if your data is perfectly symmetric, the mean and median should be exactly or almost exactly the same place in that little like peak. They're right there in the center together, or very, very close, like within a point of each other, okay? So if they are really close like that, that is symmetric data. Now, if you have your skewed right, your middle is still that kind of where that bulk of your data is going to be. And so if we're skewed to the right, our mean gets pulled higher because of these high average values. The middle will always just be the middle, but an average or a mean can move with the data points because it's, remember, adding them all up and dividing by how many you have. So it can move higher up if we have a bunch of high scores. So notice the mean is significantly greater than the median if you're skewed right. So it's kind of like your median's here at the peak and your mean's a little further to the right of that. If you have a skewed left data set, your median's still kind of in the middle of the data, but your average got pulled down. So your mean is significantly less than or smaller than the median. Okay, so that'll help us with some comparison statements. All right, so let's look at this. So the following data set represents salaries at a company in thousands of dollars. Determine if the following data sets represent a distribution which is skewed left, skewed right, or symmetric. Hint, we need to find that mean and median and compare them to see if it's symmetric, skewed right, or skewed left. So just to remind you how to do this, if you're doing the mean, we called that X bar. Remember, that was our little name for the mean. We add all the numbers together. So we had done this before the midterm. So we add all of our values together. Oops, 46. Gotta writing as I'm talking. So 46. Yeah, don't make sure you don't forget any of them. 57, 98, and 121. Now I'm already guessing my data set is going to be skewed to the right because I have all these like low scores and then I have some really, really high scores that don't really fit with everything else. But let's check it. So we have, and then we're dividing by how many scores we have. 1, 2, 3, 4, 5, 6, 7, 8. So we're going to be dividing that by 8. So that's going to give me my mean. So we'll do that. 38 plus 39 plus 41 plus 45 plus 46 plus 57 plus 98 plus 121. And then divide that by 8. That would be 485 divided by 8. That's about 60.625. So that's going to be my mean. Okay. When you're looking for a median, the first thing you have to do, oops, sorry, I was supposed to write a word there. So this is just my mean. So the mean is this. When you're looking for the median, you have to have your numbers in order from least to greatest, which they already are, and you have to find the middle. Now, if you have 9 items, there would be just one number in that group that would be in the middle. But because we have 8 items, there are 2 numbers in the middle of this group. It's the 45 and the 46. They're both in the middle of our data from least to greatest. So when we are looking for the median of an even group of numbers, so 8 is an even group, we have to take the average of the 2 middle numbers. So the median would be 45 plus 46, and you cut that in half. You're just averaging just those 2 numbers. That is 45.5. So notice the mean is larger or greater than the median by quite a significant amount. That is why my data set is skewed to the larger numbers, which means we're skewed to the right on our number line. Okay. So anytime you have quite a few
values that are all the same, and then you just have some random values that are really a lot higher than the other set, that's going to usually end up being skewed right. If, you know, the 98 and 121 weren't there, but then I had a 0 and a 5 at the beginning of my list, that 0 and 5 would be much, much lower than all the other values, and that would skew us to the left. Okay. Now, if 98 and 121 were just thrown out, we might have ended up with more of a symmetric data set because all of those other numbers were kind of close together. Okay. All right, so now the other type of thing you're going to see in your homework is they're going to give you these box and whisker plot pictures. You're not having to create these yourself. You're just looking at it as a visual guide. So notice that on a box and whisker plot, they kind of think of these as tails, but they're actually called whiskers. If you have equally spaced whiskers, they're pretty much identical on each side. And notice this little dot, the median, is just dead in the middle of that box. If you're very close to that, that's your symmetric data set. It looks like it's beautifully symmetric, okay? Now, if you see that your whisker is almost like somebody pulled the whisker one direction and not the other, notice that this whisker is being pulled towards the higher values. So that's going to be skewed right. There's some real big outliers that are really big, okay? This would be outliers that are really, really small. They're being pulled lower and lower than the rest of the box. So that's going to be skewed left, okay? So that's just visually, if you're asked to do it in your homework, we usually don't always have something like that on the test, but those are just visual guides of symmetric versus skewed, okay? All right, now this was where the original video I posted earlier today was supposed to start. And unfortunately, it did not have any ink on it. I don't know what happened. I was using my Surface. Obviously, it didn't preserve the ink. So I'm going to re-record this as part of this video, and I'll delete the other one once I get that posted. So you'll just have to watch the one video. Which of the following frequency table shows a skewed data set? So they're just asking us for skewed or not skewed. That's what we're really looking at here. Select all answers that apply. It says without doing the mean, median, and mode, because that's really hard to do. If you wanted to do the mean here, you actually have to list all these values out, the number of times that they occur. So your list would be stuff like 5, 5, and then there's 6, 5 times. So 6, 6, 6, 6, 6, and so on. Nobody wants to list all that out and try and find the mean and the median that way. So that would not be helpful. You could do a histogram if you know how to make one, and I will show you how to make one on just this first one, just so you can see that. But there's actually an easy and slick way to do this. So what you're going to look for is, remember, these are data values. So this is like numbers in our list, like we had those lists before and we had to find like the mean and median. So 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14 are my data set. That's like the actual values that someone reported. The frequency is just how many times did each of those values happen in our big list. So we have tons of data here. What you're going to do is you're going to look for the most frequent item in your list. So that's this number 10, which occurred 24 times. Okay. Now that is the tallest bar in your histogram. So remember our shapes of our histograms up here. Okay. So that's going to be that tallest bar. Typically the peak, which is where we consider that like hill of our distribution, it will be either 2 bars or 3 bars. So what I do is, before I do anything else, is I determine if my peak is going to include both sides, the two numbers on either side of 10, or if it's just going to include one of them. So here's how that works. You look if these numbers are pretty close, within 5 of your center, which there were 18 of these and 19 of those. Those are pretty close to that. And they're pretty close in value to each other. If that's true, my peak is going to be composed of all 3 bars, okay? And that's really important because that helps us determine what's left on the left side of that and what's on the right side of the peak. Now, these numbers go smaller as we go up. They go bigger as we go down. So on a number line, this would be to the left of the middle, and this would be to the right. So this is going left, this is going to the right. Okay, so if you think about it on a number line from our center. Okay, you're going to add up how many values or frequencies. So remember, these values are 5, 6, 7, and 8. We want to know how many of them are there. So we're going to add those up. So 2 plus 5 plus 9 plus 15. That's 7 plus 9 is 16 plus 15 is 31. So there's 31 items to the left of the peak we determined. Okay, then we're going to add this group. So for the right side of the peak, even though there's 4 things to the left and 3 things to the right, as long as they have the same rough number of items, we're going to get symmetric data. So this one would be 15 plus 10 plus 4. This adds up to 29 items. Okay, so the question is, those don't match exactly, but if they are within 5 of each other, so 31 and 29 are within 5 units of each other, that is an indicative mark of a symmetric data set. So this one is, no, it is not skewed, because that's what they actually asked us. This is symmetric. Now I'm going to show you how I could graphically have viewed this as well, just because I think it's good to verify that what we're doing actually works. So over here on the side, I'm going to draw in a histogram. This is our first time making our own, so I'll kind of walk you through it. You put your values on what we call the x-axis. That's that bottom line. So we have 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. Okay. And then for the frequency, that's going to be this y-axis. You just need to figure out what's the highest we get, which is 24. And you don't put all of those numbers because they're jumping by unequal amounts. We usually just count by something. So I'm going to count by 5s. So 5, 10, 15, 20, and I'm going to go all the way up to 25 since I need to get past 24. Okay, now to draw your actual bars, what you do is you kind of go halfway on each side of the little tick mark down here. So 5, there were only 2 items. So I kind of rough estimate what a height of 2 is. So the height of your rectangle is how many of them did you have? We had 2 5s. 6, there were 5 of them. So notice my bars are touching. Okay, so I'm just drawing one bar right after the other, and they're kind of half on each side of the mark. And then 7 goes up to 9, so just a little below 10. 8 goes up to 15. 9 goes up to 18, so a little less than 20. 10 goes up to 24. 11 goes to 19, so just a tiny bit taller than the one on the other side. 12 goes to 15. And my drawing is not perfect. My bars are definitely not equally dispersed in terms of width because it's hard to draw with this tablet. 13 goes to 10. And 14 goes to 4, which is just a little bit less than 5. So notice, now that I've drawn it out, you can see that that's symmetric. You actually see the symmetry very closely to a perfect hill. Okay, so I don't want to have to draw the picture for all these. So we want to just try my trick with finding the peak and adding what's on each side of that by the frequencies and then determining if it's symmetric or skewed. So for this next one, the peak, I'm just kind of jumping so I don't have to scroll down yet, but this is height number 9, the value 9 has the highest frequency. And notice on either side of it, those two values are very close to 24 and they're the same. So those are going to both be included in my peak. So the number of items to the left of my peak, because these are the smaller X values, that would be 11 items. The number of items on the right side of my peak, that's 13, 14, 15, 16 items. And this is why I said it's kind of a rule of 5. Even though those are not as close together as 31 and 29 is, if it's within 5 items, then Newton considers it symmetric enough. So this would be no to the question was it skewed? This one is also symmetric, roughly. It wouldn't be as perfect as the first one we drew because those were pretty close in item numbers, but it is still going to roughly look like a symmetric bell. Now, let's talk about the ones that don't work out that way. Now, it's just a coincidence that these two only have 2 items for their peak. You can have skewing with 3 item peaks. That's possible. But notice that the value 18 on this part B is the one with the highest frequency. Now, when I only choose 2 bars, it's because there's such a big difference between the center and one of the values. Notice 23 is really close to 26, but 15 is very far off from both of them. So I'm only going to choose my peak this time to be those 2 columns. And that is important in your interpretation, okay? So if this one's way different than the other side, more than 5, then we will not include that as part of the peak. So it gets included as the adding part. So left, this would be 7 plus 14 is 21 plus 13, that'd be 34 items. I want to double check my math on that. And then this side, for the right side, that's going to be only 17 items. Notice that's a way different grouping of items. We have so many more items that are on the left than we do on the right. So this is, yes, for it's skewed. And actually this one would be skewed towards the smaller side, which is the left. Okay. They don't ask you that in the Newton ones. They just want to know if it's skewed or if it's not skewed. But it's good to know if you are going to go to statistics later. Notice this one, 28 is the highest value for the frequency, and that relates to the value of 3. And there's, again, I would only choose one peak here or one bar for the peak on the other side, because 17 is much further away from 28 than 23 is, and they're not very close to each other. So that's going to be my peak. And then the left side, which is the smaller X values, there are 16 items on that group. And on the right side, we have, let's see, 17 plus 7 is 24, plus 6 is 30. So that would be 33 items. And again, way different in the grouping of the items. And that's why it's important to know if it's a 2-peak or a 3-peak bar, because you can't include 17 as part of the peak because it's more than 5 away from that other value that we used on the other side of the 28, that frequency value. So this one is yes to being skewed, but this time it's skewed to the larger values on our list, which would be skewed to the right. Okay. All right. And then that leads us into our last section, 7A.3. So we're going to interpret histograms because we kind of already showed you how to create one in that previous example. We have frequency tables. I don't know what happened to that. Should be tables. And then relative frequency. Now, relative frequency, we also define something called cumulative frequency. So I'll talk about that when we get to that section. But essentially, a lot of your homework in Newton, they're going to have, if they want you to make the histogram, they're going to have like little interactive bar graphs where you can drag the height of the bar up and down. Or they might just give you a multiple choice question and say, pick the correct histogram. But remember, we said it's a bar graph where there's no gaps. Now, this one right here, it looks like there's a gap, but that's because there were 0 items in that group. So this is a list of, looks like test scores that a teacher had. And notice they had some intervals. They came up with those. You didn't have to make them up. So they gave you these intervals. And they said from the scores of 50 to 58, there was only one person who scored in that group. So notice that I marked off. Nobody scored in the 59 to 67 group. 68 to 76, that'd be 1, 2, 3. So there's 3 people in that group, and so on. So that's how they came up with these frequencies. Notice they put all of those names of their score groups on the bottom. So this is their different groups that they were looking at. And then they have the height of the bar is how many did they have? How many students were in each of those classifications? So 1 student in this group, we had 0 students score between here and here. We had 3 students score between 68 and 76, 5 scored in 77 to 85 range, and 4 scored in the 86 to 94 range. Okay. So if you have that type of question on Newton where it is a interactive one, you would just have to figure out your frequencies based on what classes they gave you for your scores or your items. And then you just take that little dot in the middle and you drag it up or down to the right height. Okay. Now, something else you might encounter is they give you the bar graph and they ask you some questions about it. So, or the histogram, I should say. Selected runners from a marathon were asked how many miles they could run before they started to feel tired. So this is a survey they took. How many of those runners could run greater than 7.5 and less than 8.5 before they started to feel tired? So we start with, I usually start with the greater than case first because that's the lower number. So greater than 7.5 is heading this direction, but I can't keep going forever because they said at the same time, I also have to be less than 8.5. So essentially we're stuck at this 1 bar. Because if we go bigger than that, we will violate the second condition. If we go less than 7.5, we'd be violating the greater than 7.5 condition. So it's just this 1 bar in this between part, between 7.5 and less than 8.5. Okay, so we just need to find the height because the height tells us how many people were in that category. So that would be roughly 5. So there were 5 runners. Okay. How many of those runners could run less than 6.5 before they started to feel tired? Now notice that one doesn't have a greater than. So I just need to count everybody who was in the less than 6.5. So that's all the way down to the left of my bar graph. So that's going to be 2 separate bars I'm going to look at. So I had a 5 for this one and a 4 for this one. So 5 plus 4 would be 9 runners. So that's the answer for the second one. Okay, and then here's part 2. So sometimes they will already have created the frequency table for you, and you just have to answer some questions about that. So instead of the histogram given to you, they've created a frequency table. Notice this was an 8-point quiz for 30 students in a class. So this is all the raw data. And then that teacher went through and said, okay, how many zeros do I have? I have 2. How many ones do I have? Nobody scored a 1, so they put 0. They had 1 person score a 2. 0 people scored a 3. 2 people scored a 4. So there's a 4 there and a 4 there. 3 people scored 5, 5, 5, 5. So we're just kind of looking at the list and verifying. 6 score, there were only 2 people who did that. So 1 and then 2. Yeah, there they are. 4 people scored a 7, and then we had a lot of 8s. Actually, 16 of his students scored an 8, a perfect score on the quiz. So how many times does the data value 7 show up? That's asking frequency. How many is how many did you count? So there were 4 students who had a score of 7. Okay. Now on Newton, you'll probably just be entering in the number for that. I just like to put the object or the name of the thing we're counting, so that helps you make sense of that. Of the 30 students, how many scored greater than a 4? So greater than a 4 means you do not include 4. That would be a 5 or better, because they didn't say equal to a 4. So 5 or better. So these students in this category. So we need to add those up. So that would be 3 people scored a 5, 2 people scored a 6, 4 people scored a 7, and 16 people scored an 8. So that ends up being 25 students. Okay. And then what percent of students scored better than a 4? So we're still looking at the better than a 4, which means 5 or bigger, but they're asking you for it as a percentage. So that is how many total students did he have? He had 30. And then how many met the condition greater than 4? So that would be 25 students out of the 30 were in that condition of better than a 4. So 5 or higher. Okay. Now we want to turn that into a percent. So we're going to divide and then multiply by 100 to get it in percent form. So times that by 100. That's roughly, they didn't tell us what to round to, so I'm going to round to the nearest whole. This is roughly 83% of his students. Okay. And that's going to help us with the relative frequency talk. Okay. So frequencies are just like a tally. How many people were in each category? Relative frequency is turning it into that ratio. How many people are in this group divided by how many people did we survey or did we get exams from? So you turn those into decimal form and then you can turn them into percents. The decimal form is the relative frequency. So all you have to do is figure out how many frequencies you have in each one. So like 2 here, we would do 2 divided by 30 to figure out the relative frequency for 0. We would do 3 divided by 30 because there's 32 students total to figure out the relative frequency for 5. Okay, so we're going to try one of these. It says frequency table below shows the number of goals that Real Madrid scored in each of their soccer games in April and May of 2016. Given the frequency table below, which of the following is the corresponding relative frequency table? Okay, so notice they said which of the following. In Newton, you might have multiple choice. I just didn't want to do that because it takes up too much room. So find the relative frequency. So notice, to find the relative frequency, you have to know how many actual games did they play, because we're looking at how many goals did they play. That's our value. So how many goals did they score? But we're actually counting that for games from April and May. So there were 2 games where they scored 0 goals, 4 games where they scored 1 goal, 6 games where they scored 2 goals for the whole time, 4 games where they scored only 3 times, and 2 games where they scored 4 times in the game. Now, if we add those frequencies together, you'll notice they played 18 total games. Okay. And I did the first one for us. 2 games, we scored 0 points. So 2 out of the 18 is the relative frequency, or if you want to think about converting it, percentage of times that they played a game and scored 0 points. Okay. So 2 divided by 18 is 0.111. This next one would be 4 divided by the 18 total games. If you work that out on your calculator and round to the 3 decimal places like I did here, this one's a 0.2 repeating, so we get 0.222. 6 divided by 18, if I do that on my calculator, that comes out to 0.3 repeating, so rounding to 3 decimal places would just be 0.333. And you'll notice this is repetitive on these two because we have the same numerator as we did up above. This is a symmetric looking data set to me. Okay, so notice these are kind of percentages. If you add them all up, you actually get 0.999. So that's the total of that relative frequency part. If you have not rounded anything, which we did have to round, you would have that equals exactly 1 or 100%. Okay, so the sum of all the relative frequencies is supposed to be approximately 1. It should be exactly 1, but if you round any of your fractions off, you will get like sometimes 0.999, or you might go a little bit over because everything rounded up a little bit. So you might have 1.001, but it's roughly essentially 100% of what can happen. Okay. Now, the cumulative frequency table is where all we do to get this final column here is you are counting accumulating probabilities as we go down. Now, I don't know where that extra dot came from on that one. So notice this first part right here is just the first thing we did. So scoring 0 points in a game happened 11% of the time. The next line, when they say cumulative, means they're asking the question, what percentage of the time did they score 0 or 1 point during the game? So we take the previous total and we add it to this one, the 0.222, and that would be 33% of the time. Notice you bring that new total down for the next row. So now we're asking what's the percentage of the time that they score a 0, a 1, or 2 goals in a game. So we have our previous sum that we just got from the previous row. We add the new probability for this row, the 0.333, and that gives us a 0.666. Then we keep doing that. You bring down the new total, you add the new probability to it, and you get 0.888. Notice that once I get to the last row, it's 0.999, which rounds to 1. So your final answer in that cumulative relative frequency is that you should be ending at 1, essentially. Okay. And then I think this was the last example. So this will then be the end of what videos I expected you to watch. It'll just be this one big video now. So a data set is summarized in the frequency table below. Using the table to determine the number of occurrences of values greater than or equal to 7. So we are equal to on this one. So 7 as a value or bigger. Okay. Now we want to know how many, the number of occurrences. So for A, we're doing what is the frequencies for 7 to 12? How many people fell into that category? So that would be the 4 7s, the 4 8s, the 6 9s, the 8 10s, the 4 11s, and the 5 12s. Remember, those numbers that are frequencies means if I listed all my data out as like with commas, essentially, how many of each type did I have? Now, if we add this together, what is that? That's 10, 26, 31. Let me double check that. I'm doing that all in my head. So 4 plus 4 plus 6 plus 8 plus 4 plus 5. Yeah, 31. So that's the answer for part A. Part B, how many occurrences have a value less than 5? So that's not including 5. So that would be 4 or less. So that's this group of frequencies. There was 1 1, 2 2s, 1 3, and 2 4s. That'd be 1 plus 2 plus 1 plus 2, or 6 items. Okay. And then the final one, how many occurrences are at least 9? So at least means you are including the 9. And at least also means you're going bigger. Because if I say I have at least $9 in my pocket, I have $9 in my pocket or more. Okay. Not less. So at least 9, that would be from 9 to 12, because that's as far as our table goes. So we add those frequencies. So 6 plus 8 plus 4 plus 5, that's 10 plus 13, so that is 23 items. Okay, this is the end of what you needed to watch. I hope that it all comes out clear and that everybody can see everything. Let me know if there's any issues, and I will obviously give you a few minutes at the beginning of class if there's something you need me to clarify from this. I hope you have a wonderful evening.